welcome to this video. In this video, we want to look at how we can calculate the pH of a buffer solution. Do not forget to subscribe to our YouTube channel and follow us on our Facebook page for this and more videos. The question we want to answer reads, a buffered solution contains 0.5 m of acetic acid, which has the Ka of 1.8 times 10 to the power 5, and 0.5 m of sodium acetate. So we have been asked to calculate the pH of this solution. What can we get from this question? The first thing we can get is that the weak acid, which is acetic acid, has the concentration of 0.50 m and the Ka of 1.8 times 10 to the power negative 5. What else do we have from this question? We have been given that sodium acetate, which is this one, 0.50 m. We have been asked to calculate the pH. Now, this is a buffered solution. Now, what does it mean if it is a buffered solution? It simply means this solution will attain a chemical equilibrium. So when it attains the chemical equilibrium, there will be these major species that will be in this solution, which is the acetic acid. Acetic acid will be in the solution. We'll also have sodium positive ions in the solution. We'll also have the negative ions of C2H3CO negative. Then we'll also have the hydrogen ions. Now, if it attains equilibrium, these three species will be of our interest. The sodium ion will not be of our interest when we are calculating this buffer solution. So what does this mean? It simply means when you have acetic acid, it can dissociate to form the positive ions and these negative ions. This is a chemical equilibrium question, and you do well to understand the concepts under chemical equilibrium, because this is how this question is answered. If you do want to watch videos about chemical equilibrium, Zulua Consultants has produced a lot of videos about chemical equilibrium, and you can find them in the description of this video. Basically, we are interested to know how acetic acid dissociates to form these two ions. Now, we are going to come back to this. Let's start by analyzing the information that we have in relation to this table, which is under chemical equilibrium. According to the information that we have been given, the initial concentration of acetic acid is 0.5. Now, what is the initial concentration of H+? We have not been given the initial concentration of H+, but we have been given the concentration of the sodium acetate. So we have the concentration of these ions that are in this buffer solution. Now, if you have the concentration of these ions that are in the buffer solution, it simply means if X is lost, then X should be added and X should be added. This is what the law of conservation of mass tells us. Now, what will be the change at equilibrium? It will be 0.5 minus x. Then for hydrogen ions, it will be x. Then for the other one there, which is the negative ions, it will be 0.5 plus x. So we need to find what is the value of x so as to calculate the pH of the hydrogen ions, which we are interested in. Now, to calculate the value of x here, we need to make the equilibrium expression for this reaction. Now, what is the equilibrium expression for this reaction? Remember, the equilibrium expression, it links Ka with the reactants and the product. So, this simply means Ka is equal to, we'll start with the concentration of the positive ions multiplied by the concentration of the negative ions. Then this divided by the weak acid, the concentration of the weak acid there. So, this is the equilibrium expression that we can come up with. Now, from this equilibrium expression, this Ka, we have the value for it. We have the equilibrium expression for what should be the values of these three species. So let's plug in the values and see what will happen. So Ka we have, it is 1.8 times 10 to the power negative 5 is equal to, at equilibrium we are saying the value for the hydrogen ions concentration should be x. Then this is multiplied by the value of the negative ions should be 0.5 plus x. This is divided by the concentration of the weak acid, which is 0.5 minus x. Now, at this point, you need to take note of the value for Ka. Because the value for Ka is very small, it simply tells us that the change in the reactant is very minimal. So if the change in the reactant is very minimal, it simply means the change in x is very minute. So we can ignore this x and this x. So if we can ignore those, we are saying 1.8 times 10 to the power negative 5 is equal to x multiplied by 0.5 divided by 0.5. So what does this simply tell us? These two can simplify, and we will find that x is equal to 1.8 times 10 to the power negative 5. So this becomes the concentration of hydrogen ions that are in this buffer solution. So the concentration of hydrogen ions that are in this buffer solution, we are saying is 1.8 times 10 to the power negative 5 m. This is the concentration of the hydrogen ions. Having reached this far, we have found the concentration of hydrogen ions, which is 1.8 times 10 to the power negative 5. Do not forget to like this video, comment on it, and share it if you have found this video beneficial. Let's continue now to calculate the pH of this solution, or the pH of the hydrogen ions. Now we know that pH is equal to negative log of the concentration of hydrogen ions. So we have managed to find the concentration of hydrogen ions. So we'll say pH is equal to negative log of 1.8 times 10 to the power negative 5. So what we simply do now is to calculate on our calculator what is negative log of 1.8 times 10 to the power negative 5. It is giving us the pH of 4.74. So this is the pH of this buffer solution. What have you seen in this video? In this video, we have learned that when it comes to buffer solutions, you need to take advantage of the weak acid and come up with the dissociation equation of that weak acid. When you create the dissociation equation of that weak acid, if you have been given the Ka, make the expression of that weak acid linking to Ka. Come up with this table that will help you to analyze. And if the Ka is very small, you can ignore the value of this X. But if the Ka is large, then you need to go with the quadratic equation way, where you will come up with two values of X and pick which one is suitable for your question. After you find the value of X, you link that value of X with this equation, which is pH is equal to negative log of the concentration of the hydrogen ions in that solution. If you do so, then you have managed to calculate the pH of a buffer solution. Until next time, bye-bye.